Lesson 3.6, the mathematics of finance. Okay, this is one of the most useful lessons we'll go through. All math lessons are important because they require you to problem solve, but this one is very useful because it has direct applications referring to when you're going to get student loans, mortgages, those types of things when you're trying to put money back for retirement. This is going to help you decide and determine which options to choose when you have more than one. So the first thing, talk about simple interest versus compound interest. Simple interest is called simple interest because it's really simple. You earn interest on the principal amount, which is your original amount you put into the account. Okay, so you're earning interest on whatever money you have in there. You do not earn interest on interest earned. Okay? That is what compound interest is. Compound interest, you're earning interest on the original principal, the original amount you put in, as well as accrued interest. Meaning, you're going to earn interest, say, after the first 3 months of the year, however much money you have in your account, they're going to calculate how much interest you earn and put that into your account. So the next 3 months, they're going to calculate how much you have in your account, which includes the interest you earned the previous 3 months, and then calculate the interest you earned on that total. Okay, so compound interest, I would say, is more common, and it's going to benefit you more because you're going to earn more money. Now you're not going to earn a lot more money, but with compound interest, I maybe would earn enough to buy me an extra Take 5. Okay, so it's a good deal. So basically, to sum that up, the more times the interest is compounded throughout the year, the more money you're going to earn. So two simple formulas, one for simple interest and one for compound interest annually. We're going to get to more formulas for if it's compounded more than once a year or if it's compounded continuously. But for simple interest, we have A equals P times the quantity of 1 plus N times R. For compound interest, we have A equals P times the quantity 1 plus R raised to the N power. Okay, so what do these variables stand for? A stands for the value of the investment, how much you have at a given time in the account. P is the principal, the original amount. R is your interest rate, and N is going to be the number of years. So these are your two formulas for simple interest and compound interest annually, meaning it's compounded one time a year. An example showing simple versus annual compound interest. Suppose Brent Smith invests $20,000 at 4% annual simple interest, and James Hetfield invests $20,000 at 4% annual compound interest. Compare how much money each will have after 15 years. So if we're going to focus on Brent Smith, just simple interest annually. So we're looking for the amount. We know his principal is $20,000. It's 1 plus, our interest rate is 4%. If we write that as a decimal, 0.04 times the number of years, which is 15. So here's an equation we could use to find out how much money Brent Smith would have. Now if we set up the second equation, James Hetfield, the amount is equal to $20,000 times 1 plus our rate, which is 4%, raised to the 15 power. If we plug this in on a calculator, we get 32,000 for Brent Smith. And if we plug this one in, we get 36,018 and 87 cents. Okay, so you can see after 15 years, over $4,000 more dollars just by using annual compound interest versus simple interest. The next thing we're going to look at is interest being compounded K times per year, so meaning multiple times a year, and interest being compounded continuously. So in the first one, we have A equals P times the quantity 1 plus R divided by K, so that's our interest rate divided by the number of times it's compounded per year. And our exponent is K times T. T represents the number of years, K represents how many times it's compounded. If we look at compounded continuously, A equals P, our principal, times E. E, remember that is a constant number, 2.71828, raised to the exponent R times T. Okay, so if we look what all those things stand for, the only different ones are K, which is the number of times compounded per year, and T, which is the number of years, rather than N. Okay, so the one that's probably used most often is compounded K times per year, so quarterly, monthly, things like that. So if we look at an example of comparing compounded multiple times a year versus continuously. Suppose Corey Taylor invests $15,000 at a 3% interest rate compounded monthly, and Benjamin Burnley invests $15,000 at a 3% interest rate compounded continuously. We want to compare how much money each will have after 5 years. So if we're looking at the first one, A is equal to our principal amount, which is $15,000, times 1 plus our rate, which is 3% as a decimal, divided by the number of times being compounded, which, if we're talking about monthly, that's 12 times per year. And our exponent then is 12 times 5. The number of times being compounded times the number of years. And then if we're looking at the equation for Benjamin Burnley, we have A is equal to 15,000 times E raised to R times T. So our rate is 3% times the number of years, which is 5. So again, if we type these in on our calculators, for the first one we get 17,424.25. And for the second one, we type that in, we get 17,427.51. Okay, so you can see after 5 years, there's only a $3 difference between these. Make sure when you're typing these in, you use parentheses where needed, and just check and make sure you're doing these correctly. So far, we've just solved problems that we've solved in the past. Okay, so that should have been a review of ideas we've covered before. The next part is going to be some new things that we're going to find. Okay, so vocabulary term is annual percentage yield. Okay, with different interest rates and different times being compounded per year, it's a little difficult to compare all of the methods to determine which option is the best. So something they use is called the annual percentage yield. Basically, that takes into consideration your interest rate with the number of times being compounded per year to find a value which is called the APY, your annual percentage yield. So if you're talking about a mortgage, okay, you want that annual percentage yield to be as low as possible. Okay, so you're looking for the option that gives you the lower number. If you're talking about a CD, a mutual fund, a retirement plan, things that might earn some interest, you're looking for the value that has a larger APY. Okay, you want to make more money, so you want it to be a larger value. Okay, so finding the APY, combining the interest rate with the number of times compounded per year, gives us a solid number that we can compare more easily. A few more terms. An annuity is a sequence of equal periodic payments. Okay, so every month for my salary at the school, I get 2 checks per month. Out of each check, a certain percent, or actually a constant number, a constant value, goes into my retirement plan. Okay, that's an annuity. A mortgage on a house. Okay, you have the same payment every month that you're making on that mortgage, that's an annuity. And then we have future value versus present value. Okay, future value, the total value of the investment returned from an annuity consists of all the periodic payments together with all the interest. Okay, so an example of a future value would be money put towards retirement. If I know how much I'm putting in from every paycheck, I would want to look in the future when I plan to retire to determine how much money I have put back. Okay, considering I'm a teacher, I'm never going to have enough money to be able to retire, but for somebody with another job, that's what they would look at. Present value, the net amount of money put into an annuity. An example would be a loan or mortgage. Okay, so if I know how much the house costs, so I know how much my total is going to be that I need to get a loan from the bank, if I know the interest rate and how many years I'm going to take that loan for, usually it's 15 or 30, I can calculate approximately how much my monthly payments are going to be. Okay, so those are a couple examples we're going to go through next. So the two equations for future value and present value. Future value is equal to R, which is your payment, whether it's twice a month or once a month. Okay, that's the amount of the payment. R times 1 plus I raised to the n minus 1 all divided by I. Okay, so I in this case consists of the interest rate divided by the number of times compounded. Okay, and n is number of times compounded times the number of years. Okay, the number of payments. P of E, the present value, is equal to R. R, which stands for, again, that amount per month or the amount per check. And then slightly different in the numerator. We're going to take 1 minus the quantity of 1 plus I raised to the negative n, all divided by I. So just to make sure we understand what each of those stand for, R is the amount of each payment. I is the interest rate per compounding period. So the interest rate divided by the number of times compounded. N is the number of payments. Okay, so payments per year times the number of years. So we're going to use these in a couple of story problems now. Okay, so an example of finding the future value of an annuity. At the end of each quarter, Elias Soriano makes a $250 payment into the MVP mutual fund. If his investments earn 6.23% annual interest compounded quarterly, what will be the value of his investment in 25 years? So we're going to use the future value equation. F of V is equal to the R, the value of the payments is $250, times, we have 1 plus our I is going to consist of the interest rate divided by the number of times being compounded. So 6.23 is 0.623, or 0.0623 as a decimal, divided by 4. And that is raised to the number of years, 25, times the number of times being compounded. Okay. Then we have minus 1 at the end, all divided by 0.0623 divided by 4. Okay. Order of operations is going to be really important when you type this in on your calculators. The first thing you should do is find this value. Okay. Find out what that value is, type it in. Then you're going to subtract 1 from that value. Then you will need to divide by this value. And then finally, you would multiply that by 250. And if you do that, you should get 59,234.27. So in 25 years, there would be $59,234.27 in his mutual fund. In the last example, we're going to find the present value of an annuity. So basically, we're going to find the monthly payments for a mortgage. Jonathan Davis buys a house for $675,000. What are the monthly payments for a 15-year mortgage with a down payment of $135,000 if the APR annual percentage rate is 3.2%? So the first thing we should do is get rid of that down payment. So we're going to take $675,000 and subtract that down payment. So if we do that, we get $540,000. So that's how much his loan is going to be worth. So if we use our present value equation, we have $540,000 is equal to R. R is what we're looking for, the monthly payment in this case. R times 1 minus 1 plus I, which is our interest rate, divided by 12. So our interest rate is going to be 0.032 divided by 12, because of our monthly payments, raised to the negative 12 times 15. So we have our monthly payments of 12. There's 15 years, so we're multiplying those. Those are all divided by I, which is 0.032 divided by 12. Okay. So again, in this case, order of operations is going to be very important. What I would do first is calculate what the numerator is going to be. Okay, find out what this value is equal to. So if you get an approximation for this, we have R times that in the numerator simplifies down to 0.3808211. I would round to many decimal places so we can get this as accurate as possible. And that's divided by 0.032 divided by 12. Okay. So now, again, use your calculators, divide by that. We get R times approximately 142.8079. Okay. And that is equal to $540,000. So if we're trying to get R by itself, we need to divide both sides by 142.8079. So if you type that in and simplify, 540,000 divided by 142.8079 is approximately 3,781.30. So that means your monthly payments for that mortgage would be $3,781.30. Okay, so we've gone through future value, how much money you would have in a mutual fund if you had made monthly payments, and we determined what the monthly payments would be for a mortgage. You could apply this to finding out how much a car payment would be each month, knowing what the initial cost is, and the interest rate as well. Okay, so you can go ahead and get started on homework assignments. Also, if you look back at the story problems, look at what the names of some of these people were in these problems and determine what all of these people have in common.